Okay, we're going to finish the curve sketching of this cubic graph, and now we're going to do the second derivative where we're finding the concavity, the curviness of the graph. And so I took some information from the previous side. So the critical points where there's a min and a max are at negative 1/3 and at 10/27, and at 1, -2. So when we graph it, those are going to be the min and the max. So I'll go ahead and do that right there. All right, so to find the concavity, we take the second derivative. So here's the first derivative of this function. We take the second derivative. So the second derivative is 12x subtract 4. They both share a 4, so we're going to factor out a 4, leaving 3x subtract 1. That means the x value will be positive 1/3. So right here, we've got x is equal to 1/3, and that breaks that number line into two intervals. And in those two intervals, so we have the interval going from -infinity up to positive 1/3, and we have positive 1/3 going to positive infinity. All right, then we're going to pick two random numbers on either side of positive 1/3. 0 is always an easy one if you can use it. And I'm going to go ahead and plug it in to this part right here. Well, 12 times 0 is 0. 0 subtract 4 is -4. Well, that's a negative number, so we know this is concave down. I'm going to go ahead and put that here. And then I'm going to put positive 10. Well, 12 times 10 is 120. 120 subtracted a small number is still going to be positive. So this is concave up. And that means where x is equal to 1/3, you have an inflection point. If you plug 1/3 into the original function, I was more prepared this time, we get negative 22/27, which is not quite -1. So at positive 1/3, we're almost right down there. Let me put that in red. I'm going to put a little point right there. And then I'm going to, in blue, and I'm going to make it kind of light, I'm going to go ahead and just sketch what the graph would look like. So, oops, that is too light. The graph might look something like this. And then if you notice, so here's the concavity. And then right there does kind of here. Let me go ahead and make this a little bit bigger so you can see it more readily. If you notice, that's about where it changes from going from concave down to concave up. That point right there where it changes from concave down to concave up is called the inflection point. All right, that is it for this